More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at home is right for your child, visit mathnasium.com/at-home. Mathnasium at home, changing lives through math.
Hi everyone, and welcome back to Mathnasium Schoolhouse. I will be your instructor for today. As always, my name is Sandra. Hello everyone who is joining us. Today we have an exciting topic because it is something different, and it's even, when I first heard about it, it was definitely new to me because it wasn't something that I got to explore in my math classrooms growing up. So I'm super excited about it, and also because I'm kind of I love history. I love learning about history. I also studied it. So this is something that kind of brings us back to something you might have already learned about outside the math classroom, which are the Egyptians. Yeah, here we go. So let's take a look at my screen here. And you would have seen in preparation for today's lesson that we are going to be exploring something called Egyptian fractions. Kind of cool, right? Actually, let me know if maybe you've already learned about Egyptian fractions before, if you've ever heard of it, if you maybe know what they are and how they differ from just standard fractions that we work with in our math classes. So if you know, great, share with us. I'm sure I can learn something new from all of you. Today we're exploring Egyptian fractions in that the Egyptians did something really funky with their fractions. They only worked with what we know as unit fractions. So for example, bear with me here while I use a letter. I'm going to use a letter N here. So the Egyptians, when I say that they did something funky, the only fractions that they used looked like this. And the most important aspect for us today is that there is a 1 in this top portion of the fraction. And who can tell me what that top number is called in a fraction? Oh, someone has already learned about Egyptian fractions. Perfect. So you can help me out with the answers here. What's this number called? When we have the number at the top of a fraction, above the fraction bar, we have, I'll give you a hint, the bottom one is the denominator, and then the top one is, let's see if I have a comment come through, the numerator. Thank you, Lupita. Wonderful. So when we talk about unit fractions today in our discussion about Egyptian fractions, when we refer to that, that means that we're going to have a 1 in the numerator. Perfect. So you might hear me use these terms here and there. Hopefully we're all on the same page there. We'll also do a very brief review of some other skills we need to have in place before tackling this. So keep that in mind right now that we're going to be working with these unit fractions. And the other thing about Egyptian fractions, meaning the fractions that Egyptians used, and we know about this because we see it in some of our ancient artifacts that come up, is that to write any other fractions, they used the sum of these unit fractions, okay? But the only catch was that all of those fractions had to be different. And so we're going to be tackling that today. So let me give you an example here. Let's say the Egyptians wanted to represent this amount here. So this is just a standard fraction to us, right? We have a 3 in the numerator, a 4 in the denominator. We know, if you've learned about fractions in the math classroom already, that this is just a representation of 3/4 or 3/4. We can show that visually too. But the Egyptians would have never written it like this. They would have said, you know what, this is actually equal to the sum of 1/2 plus 1/4. Okay? And you guys can confirm that for me. Maybe do the math as you're waiting for the first exercise. Is this in fact true? If I take a 1/2 plus 1/4, do I in fact get 3/4? You guys should be saying, yeah, absolutely, Sandra, because we know that 1/2 is 2/4, and so 2/4 plus 1/4 gives me 3/4. Okay, and notice that both of these are different, right? I could have written this, of course, as 1/4 plus 1/4 plus 1/4, but the Egyptians would have said, nope, no way, that's not how we're going to represent this. All right? So one technique that we're going to bring forward from us just from looking at this example here, when we tackle some Egyptian fraction problems today, is we're going to try to find the largest unit fraction that fits into this fraction here. So going back to the number that I had before, the largest unit fraction that makes up 3/4 is 1/2, and my leftover amount is 1/4. So keep that in mind. That is what we're going to take with us in our first problem. Okay? And maybe before that, how about you guys do me a favor and in the comments list me a bunch of unit fractions that you can think of. Let's make sure we're all on the same page here. List me some unit fractions. So I will just write down the term unit fractions. What are some that you can help me with writing out? I see 1/2, love it. Yep. What else can we think of? I'm going to help you with the next one. 1/3. We've already worked with 1 in our previous problem. We saw 1/4, or I can rename that as 1/4. 1/23, look at that. I like that. Going into some funky numbers here. 1/6,666, beautiful. You guys are reaching high up into the numbers, right? And you guys are making the observation, beautiful. Love it so much. That it can be any fraction whose numerator is equal to 1, okay? My dogs are getting excited about Egyptian fractions, if you heard that. All right, so that's what we have here today. Before we carry on to our first problem, let's look at what we would need to know to tackle these. So first thing I want to make sure we are aware of what it means to be an equivalent fraction and what it means to reduce a fraction. So let's say I give you this problem here, and I'll write it out in blue. I have the fraction 16/24. And I'm asking you to reduce this fraction. How would you do this? Think back to when you learned about this maybe in the math class, maybe at your Mathnasium center. How do we reduce this fraction? So we're trying to rename this fraction in lowest terms, right? And remember, when we do that, we form an equivalent fraction, which is just a fraction with a different name, but it still represents the same amount, which is what we're going to be playing with today. So I'm not saying it quite yet. I want to reduce this fraction. I have 16 in my numerator, 24 in my denominator. Beautiful. I've just seen it pop up. So that is correct. I see the word divide. I like where that is going. Yeah, and what am I dividing by, if you want to help me out? Expand that a bit further. Wonderful. I'm seeing the right answer pop up. So let me share that right now. What am I dividing by? So someone says divide by 2. Wonderful. I can do that. What if I said I'm going to divide by 8? Oh, wonderful. Divide the numerator and the denominator by a common number. And that common number has a name. It's going to be the greatest common factor between those. So we won't review what that means to be a greatest common factor. But in this case, I know that I would have divided by 8. Why is that? Because 8 fits into 16 as well as 24, and that is in fact the largest number that divides evenly into both of these numbers. And I could have divided by 2 first, divided by 4. You're absolutely correct. It's just that it's not the largest number, so I wanted to save myself some time, some work. Beautiful. So we're on the same page when it comes to reducing fractions. We know a little bit about equivalent fractions. Let's keep that in mind for today. Let's do maybe a little bit more. What if I asked you to subtract fractions? So I'm going to take out my blue marker, and what I would love for you to do is tell me, what is 3/4 minus 5/12? So if you have a scrap sheet of paper, go ahead and use that. If you can do this in your mind, awesome job. Go ahead and share with me what that answer is. I'll give you a few seconds while I take a look at the comments. 3/4 minus 5/12. Beautiful. I see the answer. So I'm going to write it down, and let's quickly go through how we can find it, because this is definitely something we'll need when we tackle our first problem in just a second for Egyptian fractions. So one thing you might choose to do is write out the common denominator between them, right? And I don't think I saw that just yet, but I see you guys are changing your fractions into equivalent fractions to have that denominator of 12, which is beautiful. Wonderful way of showing me that. So a lot of you are changing 3/4 so that it is still representing the 3/4 amount, but it has a denominator of 12. So you guys are telling me that this is going to be, I don't think I saw it just yet. Right? Well, let's see. So how do I create an equivalent fraction here? Well, if I want a denominator of 12, I know I have to multiply this denominator by 3, which means I'm going to do the same thing to the top. 3 times 3 is 9. I'm going to subtract my 5/12, that hasn't changed. And if I do that, I get 4/12. But we just looked at reducing fractions, and if I reduce 4/12, I do in fact get to the 1/3 that you guys are sharing with me. Beautiful. Okay, so some skills that we need to have in place to look into our first problem. Okay, so I'm going to erase this. Yeah, we're not focusing on subtracting fractions today, but it is something that'll be a lot easier for you to use when you're tackling these Egyptian fraction problems. So I'm going to start off by asking you to represent 4/9 as an Egyptian fraction. So maybe take a few seconds to just think about it. You don't necessarily have to share the answer with me, but remember that we want to show this as a sum of unit fractions. So where could we start? Kind of hinted at it before. Think about that for just a few seconds and I'll help you out. What do we think? So one hint that I gave you earlier was, let's try to first identify the largest unit fraction that fits into this fraction here, which is 4/9. Beautiful. Okay, I see it appearing. So I see someone has told me that we can use 1/3 here. I like that. And just as I said that, I see another comment appearing, which is we can write first 4/9 as 3/9 plus 1/9. Beautiful, beautiful way to say it. And I love that you guys are sharing these comments. And that's exactly correct, right? So I gave you a really, really nice fraction to work with. You can break it up. And in breaking it up, you can already identify that one of the pieces is a unit fraction. On top of that, we're left with a beautiful fraction here, 3/9, because we can reduce it to be a unit fraction. So we can reduce this one to what you guys are sharing with me, which is 1/3, and I have that 1/9 left over. That's exactly right. Okay, so going back to what I said earlier, the Egyptians wouldn't have written this as 4/9. They would have said, nope, it is 1/3 plus 1/9. So you might be looking at that and thinking, well, then that's silly. So obviously math has progressed to find, way better ways of representing these fractions. And it might be silly in some cases, sure, but we'll see some problems after a few more examples like this, where it actually, this strategy applies really nicely in some of our real world problems. And so you might be actually doing this in the real world and you're not even aware that you're doing it. So, okay. Whatever you do to the bottom, you must do to the top when finding an equivalent fraction. Beautifully said, yes. Okay, so let's look at some more examples. I'm going to erase this. I'm going to ask you to please represent this as an equivalent Egyptian fraction. So again, take a few seconds to think about that. 5/8. How can I represent that as an Egyptian fraction? So one thing, as you're thinking about it, you might want to think, well, what is that largest unit fraction that fits in here? Okay. what I'll do in the same color, which is blue, is tell myself, and I just see it appearing, is that 5/8 is definitely bigger than 4/8, right? So actually maybe as a side note for myself, I'm going to write down this fact. And hopefully you've seen this symbol before. This just means greater than. I know that 5/8 is bigger than 4/8. How do I know that? Well, I can reason it out. If I have 5 of these eighth pieces, that's definitely more than having 4 than those eighth pieces. So if this is greater than 4/8, I know that 4/8 is just representing, it's another name for saying 1/2. I know that I definitely have 1/2 as part of my Egyptian fraction, right? And how do I find that leftover amount? Okay, great. I see you guys are sharing the answer. Perfect. It is going to be 1/8. For those of you that maybe don't see that right away, one way to see it is, well, I just represented this as 1/2, which is also renamed as 4/8. If I take 5/8 and I subtract 4/8, that's just equal to the 1/8 that's left over. And if you actually need to do the subtraction on the side, don't worry about it. You can just take your 5/8, subtract your 1/2, represent the 1/2 as 4/8. Squeeze that in there. And just because we have common denominators, we have a 1/8 left over. Okay, perfect. So again, the Egyptians would have said, this is what this amount is equal to versus calling it 5/8. Let's carry on with some more examples before we look at some real world problems. So I'm going to ask you to please help me with same numerator, 5, but the denominator is slightly bigger, 18. So I have 5/18, and I want to write this as an Egyptian fraction. What can I do? And I'm really interested to see how you guys approach this one, because I'm sure that there could be multiple approaches. Yeah, I'm excited to see that you guys are seeing this for the first time, and I'm quite honestly not surprised, right? There's just so much out in this world that we don't know, and especially a lot that we can learn from the past, right? How people did math way before us. Well, let's see. So let's take an approach. This is the way that I might choose to look at this. So at first I want to see, okay, what is that largest unit fraction that fits into the fraction I'm working with? Okay. Well, let me play around. Let me compare this fraction. So down here, I'm going to write down some of my notes. I know that 5/18 is definitely bigger than 4/18 and smaller than 6/18. And I did nothing more than reason to myself that 5 of these pieces is bigger than 4 of the same pieces, but of course it's also smaller than 6 of those same pieces. And this helps me out a little bit because I know that 6/18, when I reduce that, and so we reviewed what reducing means, so I'll just write out, this is just equal to 1/3. And if I reduce this, I get 2/9. Okay? But what does that tell me? It means that out of the unit fractions that I could possibly use, I can't use 1/3 because 5/18 is less than that. I definitely can't use 1/2, right? Because 5/18 is definitely not bigger than 1/2 because I know what half of 18 is. But let's see, maybe I can use 1/4. So I'm going to start to write that out, and maybe I'll use my red here. Okay, let's start with that. I'm going to take a guess and say that that 5/18 is composed of 1/4 and something else. So let's carry out that subtraction on the side to figure out what that something else is. And in fact, let me put a box here to show you that this is what I'm trying to find here. So the way that I'm going to do that is 5/18 minus the 1/4. And going back to the review we did on subtracting fractions, we know we need to find a common denominator. Not the nicest denominators to work with, but if you remember some of your review of fractions, one very easy way to find a common denominator is to just multiply the denominators we already have in place. So one thing that we can do is multiply 18 times 4, and if you do that in your head, you can, or on your sheet of paper, you'll get 72. Okay. And that means 5 times 4 is 20. And over 72 here, and I apologize that my marker is dying. Let's do that. Over 72, here I get 18. Okay. And this gives me 2 over 72, which the nice thing about this, if I reduce this, actually gives me a unit fraction, which is 1 over 36. So voila, I have my representation as an Egyptian fraction. Okay. Now, some of you might have thought, well, I don't like that approach. I could have actually shown this a different way, which is true. So let's go back to my reasoning down here. So I'll erase this in just a second because I'll use a different method. My reasoning could have helped me out here as well because I know that 5/18 is larger than 2/9. But what does that tell me? Well, 2/9 is bigger than 1/9. So I could have used 1/9 as my starting point and then performed that subtraction. So one other thing that I could have done here, I'll just erase this. I'll take this box off. I'll keep this one here because it still is true. But I could have also said 1/9 and then found out this result by performing the subtraction again. But in this case, I'm subtracting 5/18 minus 1/9. Right? And if you do that, you would get 1 over 6. So you can already see there may be, in many cases, multiple ways to represent the fractions we're working with Egyptian fractions. Okay? And you can confirm that by adding the fractions up. Okay? And hopefully you're understanding the different ways that I took to find those. So I'm going to give you 2 more. So let me ask you to please find, and let me use a different color, 11 over 24. The numbers aren't getting too nice, are they? 11/24, I should say, not 11 over 24. 11/24. I have 11 of these equally sized pieces. All right. How would I represent this as an Egyptian fraction? Okay. So I'm going to reason out by thinking, okay, 1/2 doesn't fit into my 11/24 because 1/2 with the denominator of 24 would be 12/24. So 1/2 is out of the picture. Let's say I have 1/3. Okay. If I perform that subtraction, what do I get? Well, let's see. 11/24 minus 1/3. I can create a common denominator here of 24. And what do I get if I do that? Great. So I'll have 3 over 24, which is I think what I'm seeing here. I'll have 3 over 24, and if I reduce that, what do I get? I'm not sure that I saw it just yet, but I would get 1 over 8. Okay. Where this was the largest unit fraction that could fit into my 11/24. Exactly, added by 1 over 8, and there we go. And then I just found that remaining piece. Perfect. So last one I'll ask you before we tackle a word problem is, well, what about 23/24? Here is a situation where I could definitely use 1/2 because, as I pointed out earlier, 1/2 would be 12 over 24, or I should say 12/24. right? 12 24ths. But here I have 23 of the 24th pieces, which means I'm definitely have a full half in there. Okay, so if I take that and I find my result, what do I get? What am I doing? 1/2. Right. I'm going to actually get 11 24ths, which should remind you of the problem we just worked on, which we found was 1/3 plus 1/8. Okay? Pretty cool, right? So let's see how this works out in a word problem. I'm going to convince you that you're going to use these at some point in your life, and you might have already used them. So let's see. Let me remove this. Okay. And I'm going to pose a problem, which is that you have 5 loaves of bread. Oops. Make sure that's appearing for you. 5 loaves of bread. And you want to share these evenly amongst 8 people. All right, how would we do this? Think about that for a second. Okay. We want to share these evenly. I didn't write it down, but we want to share these evenly. So how would we do this? Yum, I agree. How could we do this? Okay, so your mind might jump to, oh, I know this. I've done a lot of fraction word problems, and I know that what I have to do is take these 5 whole pieces and divide it by 8. Which could be true. And so what I've prepared for myself here are these cubes linked together to represent my loaves of bread. So let's say I have colorful loaves of bread, right? I have a blue, an orange, I should say a light blue, an orange, a dark blue, a red, and a brown. And you'll see I've created them out of 8 cubes. So one way I can divide this amongst my friends or my family is to give them each 1 slice of each colored loaf of bread. Okay? And then continue, give them an orange one, give them a dark blue one, and so on. Okay? Hopefully, if you think of these as bread and not just cubes that we can play with in the math class, right? Yes, banana bread, better. So it's not just standard boring bread, right? Hopefully what you start to think is, well, oh my goodness, if I have to cut up 5 loaves of bread into 8 slices, okay, that's not only a lot of work, which I want to minimize how much work I have to do so I can save it for some more fun stuff. It also means that I'm losing, get this, I'm losing a lot of crumbs with every cut I make, which means all that banana bread that could be in my mouth, right, that I could be sharing with my friends, could be in my belly, is ending up on my cutting board, and no one's going to eat that. It just goes to the garbage, which we don't want that. It also means that I have to cut every loaf of bread into 8 equal-sized pieces. And I don't know about you, I can't even divide a circle nicely into 8 evenly sized pieces. And every time I cut a loaf of bread, it definitely doesn't come out equal, right? So I'm not going to try to do that if I don't have to. All right? So I don't want to take this approach of taking each loaf of bread and dividing it into 8 equal-sized pieces and sharing that. But it is an approach. It's not wrong. So the way that we would approach this using Egyptian fractions looks like, well, what would have originally been the 5 divided by 8, the 5 loaves of bread divided into 8 equal-sized pieces. Instead, we can find a representation using Egyptian fractions and just cut our loaves of bread that way. Okay? And given that this is 5/8, we did this earlier, we can represent this as 1/2 plus 1/8, which means if I take my loaves of bread, I'm dividing each of them into half, okay? So let me actually show you this using an image. So if I have 5 loaves of bread, 2, 3, 4, 5. Instead of cutting them all into 8 pieces and giving everyone one of those pieces, I am going to cut them into half. So I have 1/2, 2, 3, 4, 5, 6, 7, 8. So I'll give everyone 1/2 of the bread. Then I have one more loaf of bread left, and so this one is the only loaf of bread I would divide into 8 equal-sized pieces. So everyone gets 1/2 and 1/8. I prefer that. Less cutting, less crumbs. I'm happy. Let's maybe do one more problem. Let's look at pizza. Some of you might prefer pizza over bread, so this one might be more interesting for you. So let's see instead if I order 4 pizzas, right? I'm going to order 4 pizzas, and I have to share this equally amongst my friends again, because if I don't, they're going to get mad at me. We all want the same amount of pizza. So if we order 4 and there's 5 people, I have another problem again, right? It doesn't divide nicely. So order 5 pizzas, share with 5 people. Evenly. We always want to share evenly. We want to share always equal-sized pieces. So once again, I can take the approach, so I'll erase this in just a second, but yes, I can take my, usually our pizzas are circle, so let's say again it's a circle-shaped pizza. I can take each of them and cut them up, slice them up into 5. So I'm going to do my best to represent 5 here. Ish. I can cut it up, slice it up into 5 pieces each of them, but going back to my initial problem, it's hard enough for me to draw it. Slicing it up into 5 equal-sized pieces, someone's going to be upset. They didn't get the same size. So I'm going to try to avoid this situation. I'm going to erase that, right? So what could I possibly do? Well, the Egyptians can help me out, right? I don't even think the Egyptians ever had pizza, but here they are helping me out with a pizza problem. How cool is that? So what I could do is take what originally would have been my problem of 4 whole pizzas divided by 5 equal-sized pieces and rewrite this as an Egyptian fraction, which I know could be 1/2. I definitely know this is bigger than 1/2. Okay. And I know that there is also 1/4 here and 1/20. And you can confirm that for yourself using the approaches we took before. So I'll just show you the math here in case you want to prove this later on. Okay. So I know that this is bigger than 1/2, so I started off with the 1/2. And so 4/5 minus 1/2, you can rewrite this as equivalent fractions and say we have 8/10 minus 5/10, which leaves me with 3/10, and then break this up into unit fractions. So this is the answer here. Another way you could possibly see this, if you don't like this math right now and you need to see it visually, not a problem. Draw yourself 4 circles. Let's see if I can fit 4 in. There we go. That's not even a circle. Let's do that one more time. Okay. So once you've given everyone a half, so 1, 2, 3, 4, 5, you'll see you're left with a half and a whole. One approach would be to take that and to divide it into quarters. So everyone then gets 1/4 as well. And then you're just left with 1/4. So the best way to do that is to divide that up into 5 pieces. But each of those pieces are pieces of the whole, and they're actually equal to 1/20. Right? So you can look at it visually, or you can perform the math. How about we tackle just one more, and then we'll end off for today. Okay. So let's say that we have, let's do this one. So we have a butcher, okay, someone who works with meat for a living, and this butcher has 10/21 of a kilogram of meat. Okay. And to minimize how much he has to cut up, he wants to only cut this meat into 2 pieces. Okay, let's keep that in mind. This is how much he has. He wants to cut up into 2 pieces, just to make it easier. Okay, and he wants each of those pieces to be a unit fraction of a kilogram. So right away you're thinking, I'm approaching this using unit fractions. Okay, so let's rewrite this as 2 unit fractions added together. So go ahead and think about that for a few seconds and tell me what should be in each of these denominators, and then we'll be done for today. I'll give you a few seconds to think about that. You guys are getting all hungry with these food examples, I can see. What do we think? Oh, I see the answer appeared. Great. So I see 1/3 plus 1/7. Beautiful. So let's see how we could possibly get that. So again, this butcher had this much of meat, 10/21 of a kilogram, wanted to only cut it up into 2 pieces, and he wanted each of those pieces to be a unit fraction. It's just that much easier to cut it up. Okay, so let's see. Well, we're going to maybe take the approach of what's the largest unit fraction that can fit in here. So one approach that you could possibly take is to consider the fact that 10/21, I can rewrite this as 7/21, or 7/21. So let me write this as this. And I'll tell you why I decided on 7 and 3 in just a second. Maybe I'll write this here. Okay. So what do you think? How do you know, how do you think that I knew that I can divide this up nicely here? Well, one approach that I could take is, what I was thinking in my mind is, rather than doing all that subtraction, if I don't need to, I won't. Just eventually when you get more practice with math, you kind of take that approach with a lot of problems, is let's try to minimize how much work we have to do here. So 10 of these pieces is also equal to 7 of the same pieces plus 3 of the same pieces. Why? Because 7 plus 3 is equal to 10. And the nice thing about 7 and 3 is that they are factors of 21, which means that when I reduce these fractions, I get back to unit fractions. Right? And you can go ahead and do that math in your mind right now. If I reduce 7/21, or 7/21, I get 1/3, because 21 divided by 7 is 3, and 7 divided by 7 is 1. And go ahead and do the same thing over here, and you'll find that that is true. So this butcher can actually be successful in cutting up this piece of meat into 2 pieces and having them as unit fractions. I'm going to end it off there. You will find more practice in the practice worksheet that will be shared with you just after today's lesson. So go ahead and take a look at that. I hope that you can already start to see that this is something that you probably are already doing on a daily basis. And that the Egyptians actually had something going here, right? It's a nice approach to take in many situations, and it's not something that we have to discard. It's something that we can take with us, even after learning about fractions the way that we do in a math classroom. So I hope you learned something new today. I definitely enjoyed prepping this lesson for all of you. Enjoy. As always, these lessons are available on our Facebook page for viewing afterwards if you need to revisit an example. Join us again tomorrow for our next Schoolhouse lesson. I will see you later this week. Have a wonderful day, everybody. Bye-bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.